Welcome to the first in a series of 3 discussions on texturing. Today we're going to be talking a little bit about Photoshop, Photoshop basics. We will be delving into Photoshop a little bit. What basic maps we need, what they should contain, what kind of information do they contain, and different file mapping methods. Just like there are different ways to lay out UVs, there are different ways to assign textures or maps to materials or objects. You're going to be downloading the Thermos logo zip from lesson 7. We're going to be projecting the Thermos logo onto the Thermos. And I've also got an SAL logo in there as well, so download that. That will be projecting onto the table in the exterior scene. So you guys will have a chance to work with the day versions of the interior and the exterior. All right, office hours next week, next Wednesday, it'll be the same, 11 a.m., basically 11 to 4 p.m. Hour in there, off for lunch. Available at other times, let me know. This Friday in my office from 11 to 1, I'll be available then. I found an open lab at 1 o'clock, so I will be in 4B 128. If you need to make up hours, make sure you come if you can. If you need help, run in there. We'll give you some help if you're on break. Don't forget, integrated learning 8. We're winding down on those. Number 8 is from 10 to 1 p.m. on Saturday. This Saturday will be our last Saturday. Yes, I know, very sad. Yeah, can all watch cartoons next Saturday. Except that's not even a thing anymore, because you can watch cartoons all the time, anytime, pretty much wherever you want. But for me, that was a big deal, because that was my treat, even as an adult. All right. So, as I mentioned, basic Photoshop tools, basic maps, and file mapping methods. All right, if you are new to Photoshop or if you have used the older versions of Photoshop, I started way back before there was Photoshop and came up through Photoshop 1 all the way to now. The interface changed a little, mostly the icons, mostly the background, but the tools, the basic tool set that we use all the time pretty much has remained the same. The tools have always been on the left side. Your image has always been in the main part of the window. And we've always had a layer kind of submenu off to the right. Layers, channels, paths. They were the big 3. Paths only if you're using vectors or you're doing Bezier curves. Channels, that contains the red, green, blue information. If your image is black and white, it will just contain black and white information. But that also is where we will find red, green, blue, and an alpha channel if your file contains it. And we will be creating some alpha channels if you are going to be doing things like the wine label for the exterior scene. All right, now, when you select a tool in Photoshop, doesn't matter what tool it is, across the top, underneath the main menu set, you will get tool options. Very similar to Maya's attributes. All right, tool options will give you things, if you choose a brush tool, obviously it'll give you brush size, brush hardness, the opacity of the brush, the flow of the brush, whether the brush behaves in a normal fashion or it uses a blend mode to blend with other layers. And that's the big thing about Photoshop. Photoshop is an image editing tool. So layering in Photoshop is really its, not primary function, but its real strong point. That and being able to edit pixel by pixel an image for cleanup, for distribution. I mean, this is pretty much the tool they use for high-end touch-up work. Now, as far as texturing goes, there are other tools that you can use. Substance, for instance. Substance Painter would be the tool. You won't want to use Designer for painting work. Designer is good for designing networks and, different parts of the networks, not just base materials, but spec, glossy, metallic, normal, height maps, you name it. You can design all that into a material, tell it how it should behave. But Painter is the one that's going to give you the ability to paint in 3D different parts of your map. Photoshop has some 3D functionality, but its strong point is really just 2D. They tried to overextend Photoshop a little bit too much, especially when they went into the timeline and they tried to do animation with it. But use it for what it's good at, image editing. It's also how we are going to make repeatable or seamless textures next lecture. So if you have a tablet and you would like to bring it, it'll work a little bit better. I mean, you can use a mouse, but it's kind of like using a brick of soap compared to a pencil. But if you're comfortable using a mouse, by all means you can do it. It's just that it's a little easier with, paintbrush, clone stamp, healing brush, doing it on a tablet. Having said that, I usually forget mine and wind up with my mouse, but I'll try to remember it. All right, now, before I go any further, let's talk about what you guys are going to start today in lab. So, you guys have made it through basic rendering, basic lighting, basic materials. Now we get into picking one of the environments that you have done, the interior day or night, or the exterior day or night, choosing one of those, and you will texture it through to finish. Now, every object in your scene does not have to have a texture. Textures are used when you need to have more than one color on an object at one time. For instance, the floor, our carpet. Single color, multicolor? Multi, right. So we would use a map for that. Wall, single color, multicolor? All right, so we could probably just use a material for that. Maybe throw a bump on it, maybe throw a little, a little bit of dirt, a little bit of grime later on. But to define that property, we can get away with a material. All right, no point in wasting a good map if you don't need to. Now, having said that, in games occasionally you will find them using 1 pixel color chips in order to define color. Because in some game engines it takes more computation to define color through a material than it does with a map. So depending on what your needs are, I used to do simulation on the Space Coast, and everything we had for the viewer that we were working in had to be defined with a map. But if you don't have to do that, it's much easier with just a material. Create a material, change the color, you're done. Especially, Maya, that's what it's built for. All right, so things like glass. Do you need a map for that? No, absolutely not, because you can define that with material. Candles, candle holders. Candle holders, it could go both ways. It's hard to tell. If you're doing something like brass, if it's brushed, you probably need a map in there, but maybe not to define the color, just to define the roughness or the bump. Yes?
With glass, if it has a texture, would you just use a normal map on it? Would that affect how the light plays with it?
We're going to get into that today. For rendering with software, you could use a bump. It's much more efficient than using a normal. Normal map is basically for real time. But it's kind of the same thing. It's just that normal maps, you're defining blue and red to change your height. In bump maps, it's just black and white to change height. So it's kind of the same thing. Normal maps for real time, bump maps for software rendering. Say your glass has a kind of a bumpy, wavy look to it. That would not be defined in the color though, right? That would be defined in what we would call surface relief. It looks like it has roughness to it, and that would be with a bump. But technically, yes, it's with a map. But if we're just trying to define color and basic information, base information, if you will, we would just use material. Same thing in real time with a game. You apply solid color to it, and you throw your normal map in and do your stuff. All right, for the interior, you have some things that you do not need to have maps on. Again, glass would be one of them, unless you're doing something with a decal on it, or you choose to take the vase and make it into some kind of porcelain painted object. Then you would definitely need a map to define that. Things like the thermos, the brushed metal, don't need a map for that unless you choose to put a roughness map in or a bump map to get the grooves of the roughness, microscopic grooves. In my example up there, I chose to use wallpaper, but if you choose to do a solid color, again, think walls. Don't need a map for that. All right, does that make sense? So you're choosing one of them. Don't stress yourself out like you got to do both. Also, please do not underestimate. You may think, oh, wow, that's easy. I'll just go grab some textures off the internet, throw them on there. Sounds easy. But until you actually start getting in there and putting them in, making sure they're the right scale, making sure they look good, it's going to take work. We're going to drill down into this little by little. Today we're going to talk about how to assign textures, basic types of maps you're going to need. Not required for every object to have 3 maps, but we're going to go over what each map defines. All right, so some milestones for you guys. You definitely want to have, you need to have at least one projection, which is like a decal in a game. All right, so if you're doing the interior scene, I suggest you do the logo for the thermos. If you're doing the exterior, you can put the SAL logo that I supplied. You could also put your initials. You could put something there. It's got to be PG. Yeah, I know. It's a big disappointment for everybody. No porn, no hate, nothing. Yeah, I guess so. Yes.
Does the projection have to be on the table? Because I was thinking of theming the window at the back of the pizzeria and putting a logo on it. Would that be okay?
That would be fine, yeah, you could do that, as long as it's projected. All right, so that's what you, basically for today, you guys, remember how you went and you looked for look development, right? Reference, how to make materials. You're going to be doing the same kind of thing now when you start looking for textures. You need look development. In your collage above your renders, you're going to have the same kind of information. You're not going to put textures there. You're going to use look development. You may say, okay, well, I had a sofa in my daytime scene. I really didn't like it. I used it just to kind of get stuff going. But now I found another sofa I want to use. Yes, absolutely. Use your new sofa. Throw that in your reference. Get rid of the old one. Do whatever you need to do. Same thing for the exterior scene. If you choose to change the table, you change the chairs. Remember, those chairs in the exterior scene, they are canvas director's chairs. Right? They're meant to be wood frames with canvas, fabric, backs, and seats. They don't really translate well if you try to make them. I've had people try to make them solid metal chairs or plastic. They don't really work just because they were built to be, folding chairs, pretty much. Kind of chairs that you would sit down in and go, wow, this is uncomfortable, we better eat and leave. So they can turn over the restaurant. All right, so next lecture, we're going to be making repeatable textures. Scene looks eerily familiar, yes, I know. We changed a few props in it. We're going to be making a seamless brick wall, a seamless wood floor, and a seamless kind of alligator skin, organic looking texture. All three of those represent different levels of difficulty when making a seamless texture. When you're making a seamless texture, it's easy to do stuff that are straight lines and right angles, right? Pixels are square, so pixels do really well with straight lines and right angles. Same thing with trying to make something repeatable. When you get into having something with grain where you no longer have straight lines, you've got things that curve, or you get into kind of a cell-based texture where you've got columns and rows, but they are not organized, they weave and they're organic looking, represents a few challenges. Anything we make or you choose to make from lecture next time on Saturday, you can feel free to use in either the interior or the exterior. If you want to use a brick wall, great, go for it. Throw it outside if you're doing the exterior scene. Throw it inside if you're doing the interior. I would not use the brick wall for a floor inside. That's just wrong. You find very few of those, unless it's a patio, which this is not. Unless it's a patio, that's not going to work. All right, and then we're going to be adding some wear and tear. Spec maps, dirt maps. We're even going to get into using this thing called cutout opacity where we can remove portions of the geometry at render time. So you can create torn edges in Photoshop or Painter or whatever you decide to do. You can create torn edges, throw them into the opacity map. We can get rid of it at render time. We'll be putting at least a watermark stain on the inside, at least one, and you'll be putting wine stain on the exterior if you're doing that. You need to have at least one of those in there. All right, does that make sense? Any questions? Okay. All right, so let's talk about simple maps and what they contain. Like I said, if you have reference that has an object, it's got more than one color on the surface, and it is a single surface, for instance, tabletop here, this kind of faux wood grain. Single color, multicolor? Multi, right. So you need a map for this. You can't define that. How about the rubberized edge here? Single, right? So we could probably get away with a single map there. Not a single map, single color. All right, so diffuse maps, they contain color information. They also contain visible texture information for your surface, visual detail, if you will. They get plugged into diffuse color. Pretty simple, common sense, I would think. Spec maps. This allows us to control reflectivity on a surface. For instance, my example here is 12 by 12 inch vinyl tile. So, any low-lying areas on that tile, because you guys have all seen tile like this. In fact, we probably have some outside here in a couple of the buildings. All right, you've got areas where it looks like they've got smaller tiles, right? This is meant to look like fake ceramic tile. All right, but low-lying areas where this would normally be grout, they're kind of stamped or pushed in. You're not going to get as much light hitting it as a surface that stands above it. Makes sense, right? It would be occluded. You guys know about occlusion maps, right, for modeling? So light's going to come down, it's going to hit, it's going to graze off the higher surface and kind of skim over the little valleys, the little, pushed in areas and create a little bit of a shadow. That means it would not reflect light as much as the raised parts of the surface. And we use spec maps to control on a surface, a larger surface, which parts are reflective, which parts are not. Spec maps contain just black and white information. That's because in our reflection channel, in the MIA Material X, in Arnold, in RenderMan, we have a color chip there. It's usually 0 to 1, black and white. Of course, it could be another color, but when you get into coloring reflectivity, you're changing the properties of the material. So we generally leave reflection channel spec maps usually at white. And if they're a metal material will pull in color and do that for you automatically. But spec maps, black areas are non-reflective, white areas are completely reflective, gray somewhere in between. Don't get me wrong when I say black and white map. It doesn't have to be black or white. It can be gray. You have transitions between really glossy, really hard, smooth surfaces to areas that are rougher. Does that make sense? Any questions about that? All right, bump maps. This is what we call surface relief, visual detail, visual surface detail. Again, a black and white map. Low-lying areas that you want to look like your geometry's pushed in are black. High areas are white. If you want no change at all, if you don't want it to look like it's got, it's either embossed or etched, then that's 50% gray. All right, so the way bump maps work, kind of similar to the way normal maps work, is got a surface normal pointing at the camera. When your surface normal points at the camera, you get the most visual bump. As the angle of viewing changes, the bump effect gets less and less. So by the time your normal is 90 degrees to the camera, there is no surface relief at all. It's an illusion. We don't change any of the geometry. We don't change anything on the surface. It's pure illusion. Now, there are different maps that we can make called displacement maps, which we'll get into in the last lecture, or actually in lecture 10, not last one. Lecture 10, we'll talk about displacement maps. And displacement maps physically change the geometry at render time. But we like bump maps because they're cheap. They don't have to retessellate your geometry. You guys know about tessellation, right? Process of converting quads to tries, and based on your edge, how many tries are there. Now, the MIA Material X has a couple of channels that you can plug bump maps into. I think Arnold's got one, RenderMan's got a whole bunch of sections. RenderMan's just a party of bump maps and normal maps you can plug into. But basically, all of them share one thing in common. There's one that's overall, which means it applies the bump effect to both the diffuse part of the material. That's the part where it's visible even if it's not shiny. And also what we call the spec component, the shiny part. It applies it to both of those. All right, so overall, standard, they both function the same way. The difference is standard has a switch on it, which allows you to turn off the bump part on the diffuse. So it looks like you're coating, it looks like the surface has a coating on it that's bumpy rather than the surface itself. If you've ever seen ceramic fired vase or figurines, a lot of times they look nice and smooth. You hold them up to the light and kind of move it around in the light, you can see a little bit of wavy pattern in there from when the glaze, kind of runs a little bit in the firing process and the cooling process. Because remember, with ceramic, you got to lower the temperature gradually, because if you lower it too quickly, you wind up cracking it. You wind up with those hairline cracks you see in really cheap glazed objects. So it takes a lot of time. So, things are still kind of molten when you've got a couple thousand degrees on the surface. So by the time it cools, things tend to shift a little bit. It's all part of the charm of ceramic. Right? But that is the coating and not necessarily the sculpt or the vase that has that surface relief on it. And that's why we have this standard part of the bump. All right, before I get into mapping methods, let's take a look at what this looks like in the MIA Material X. All right, so if you guys want to follow along, all I'm going to do is make a plane, a sphere. I'm going to throw on probably the exterior scene for exterior IBL HDR image we've got, just so I have something to reflect. And I'll put in a directional light. Just need a directional light. Turn on final gathering. And we can take a look at what happens with bump mapping. Then I'll talk about the other maps too. But sometimes bump mapping is, if you've never used it before, sometimes people get a little confused. All right, so I got my lazy button to create a plane and sphere. First thing I'm going to do is I'm going to assign an MIA Material X to the ground plane, default. Why the ground and why not use the same material for both? Because I want to apply a bump map to my sphere and not the ground. So you need to have separate materials, just like with the real world. All right, so sphere. All right, going to create an IBL, very simple, render settings, scene, environment, create, there we go. All right, in my IBL, I'm going to throw my HDR image from the exterior. I happen to have my project set from last lecture here. So DH211, there we go. All right, so by default, don't forget, anything we give you that has LP after it, that's a light probe. We change the mapping to angular. All right, so brand new scene, so viewport 2.0 should be active automatically. All right, so my sphere is on vacation here. I am going to also throw in a directional light, just for good measure. Why not? Nice thing about the directional light, doesn't really matter where I put it. It only matters where and how I rotate it. So we'll make it just so it aims away. There we go. All right, one other thing I'm going to do in the render settings, turn on final gathering and make it cheap. And by cheap, I mean turn down the indirect diffuse quality. That way I'm not sitting here waiting for an hour. So right now this is flat gray. Well, not flat, but it's got reflectivity on it. And it's really getting kind of blown out here. All right, what I'm going to do is just turn off my, there we go. I'm going to turn off my linear color space so it's easier to see. Good. All right. So what I want to do is I'm going to apply a simple, basic, built-in Maya texture. What I'm going to use is one of what we call the built-in procedural textures. Procedural textures, they are computer-generated textures. They don't use pixels, they use math. And basically, the beauty of a procedural texture is you can make it as small as the head of a pin or as large as a barn or the side of a building, and you won't lose resolution. It will maintain integrity because it just rebuilds itself because it's a piece of code. Right? They have their downsides, but programs like Substance use them all the time to procedurally generate noise and dirt and ways to make things look random. Maya started out using them. I mean, Maya's had them since the beginning, but they never really did anything with them. Not until Substance came along and goes, wow, look what we can do. You know, they figured out that they could actually use it to generate really good looking stuff. Whereas Maya just implemented it and then walked away. You find that happens a lot. Good ideas sometimes are just thrown by the wayside. All right, so first thing I want to do is find out where I plug my bump maps into. So bump maps go into the bump attribute, which is down toward the bottom of the surface. You find it's about 6 up from the bottom, right here, right above advanced. Now if I expand bump, you'll see I've got overall, I've got standard. Let's look at overall first. Overall, as I mentioned, is going to apply that bump or visual surface relief to both the diffuse part of the material and what we call the speck or the glossy part. If you're not familiar with assigning any textures or any materials, this little checker button on the side is what you click, and that will bring up what we call the Create Render node. Now, when you click on that little checker button, Create Render node will highlight 4 attributes or 4 sections of things that can be plugged into it. Right? You could try and plug other stuff into it, but it's not going to work. So Maya knows what will work in that attribute, so it limits it for you. You have a choice of 2D, 3D, environment textures, other textures. We'll get into other textures. That's where what we call the layered, or it's the layered texture lives. We'll get into that in Lecture 10, how to layer stuff in Maya. Environment textures, we really don't use those anymore because we've got environment spheres that we use that are created by whatever renderer you're using, whether it's Arnold or RenderMan or Mental Ray. They all have their own environment spheres you plug images into. What we're interested in is 2D textures and 3D textures. And notice that when I deselect all the others and just choose one, it limits what's available to me. So you can automatically kind of filter it down. Now, anytime you want to plug a map in from, say, Photoshop or something you've got off the internet, you're going to use 2D. And you're probably going to use a file node. If you want to use one of the Maya procedurals, well, they've got things like a bulge, a checker. You guys should be familiar with the checker. You probably used it for laying out UVs. That is actually a procedural texture. It's just a bunch of math that says you'll make squares, and when you run out of squares, you make more. And if you resize those squares, we'll make them smaller or bigger. If you make them repeat, we will force more onto the surface. And if we have to make more on the surface, they have to get smaller to fit more in. And that's basically what it does. You've got a couple other things like fractal, grid, something called a Mandelbrot. Sounds very sexy, but it's not because it only works with Maya materials. It's basically a fractal. If you're not familiar with fractals, look them up. Mountain, movie, a lot of these are noise-based. They're basically kind of randomly placed parts. And by that, I mean they could be black and white colors. They could be more than one color. They could be 2 or 3 colors. And they are either in a noise or speckled pattern, or they're in some kind of cloudy pattern. And those are 2 of the big procedurals that we have. Most of the cloudy stuff is 3D. Most of the noise-based stuff is 2D. All right, so what I'm going to do is I'm just going to select noise because you guys already know what the checker looks like, so I'm just going to go with noise. So now when I plug noise in there, I'm going to open up my Hypershade and graph the network so you can see what happened. So here's my sphere. I'm going to right-click, graph network. When I zoom in on my material X, you can see plugged into my overall bump, Maya automatically gave me something called a bump utility. That bump utility allows me to control how that bump is placed on the surface and also to what degree do I see bump. It's basically the depth of it or how much. Now, plugged into that bump is my file. That happens to be a noise. And that is just driving my height, black and white. Plugged into my noise is something called a 2D texture. A place 2D. Place 2D controls that noise in UV space on the surface. That's why it's 2D. If I place a texture in 3D, anybody want to guess what would the coordinates be? First off, in Maya, what is your coordinate system? Right. That's how it would place it in 3D. X, Y, Z rather than U and V. Remember, UV, 2D. 0 to 1 space. So this is a 2D texture, so we have control over the 2D place right here. Coverage, if it's 1 to 1, that means it fills up the entire 0 to 1 UV space. Translate the frame, that simply moves, that means you can move it around in 2D space. Translate it, 0.25 would be a quarter in your frame. Everything's 0 to 1. Rotation, that simply allows you to rotate. So let's go 90 degrees. So it allows you to rotate whatever image you have on there, and it rotates the actual UV frame, not the UVs themselves. This is in degrees, which is nice. So by default, set it 0. We can wrap, which means it will continually repeat itself until it covers the entire surface. Repeat, we use this to make that texture copy itself onto the surface. So if I double it, you can see what happens. It made it smaller. So if I make it smaller again by telling it to copy itself more, that's what I get. Now we're starting to get like that kind of speckled, they call it throw-down ceiling you see sometimes in a lot of Florida buildings. Stucco sometimes is thrown down like that. Yes? When you can use bump map, if your surface has visible relief. Do you see texture on the surface? Your surface doesn't have to be, let me see. Your surface does not have to have, it can have more than one color, but it doesn't have to in order to be able to use a bump. Normal maps are for real time. Bump maps are for software rendering.
But when we use normal maps, we just copy.
You're looking at it in the viewport. Right. When you render, you're rendering it out in either Mental Ray, Maya, Arnold, or even Maya software. You're waiting for it to render. You use a bump map to see the surface relief. Also, different information. What color are your normal maps? Yeah, kind of magenta and cyanish, blue and red. Right? Normal. Those are normal maps. Bump maps are black and white. Bump maps, software rendering. Normal maps, real time.
So what I was taught, they said that normal maps gives you more detailed information because it depends on a pixel and where it, like the angle of each pixel. When in bump maps, it looks at the like higher or lower because it uses just black and white.
Uses black and well, uses gray also.
I mean, yeah, from black to white, so like the scale.
Right, but it's also based on the angle of the normal to the angle of the camera.
Oh, okay.
So they can both kind of do the same thing. But like I said, if you're doing software rendering, which you are for us, you need to use bump maps.
But if I need to add that noise, not the noise, like a texture to my sofa or pillows, can I use bump maps or I?
You have to use a bump map.
Okay.
Now, don't use the word texture because texture implies visual surface. Like texture, right? As opposed to having visual surface relief, like this is smooth,
Yeah, but like this rubber,
Right.
it has like noise in it.
like right here. It's got a little bit of noise.
So this is bump.
Is that single color or single color, right? So you could assign a black material to this, right? Turn down the reflectivity a lot. To get that look, you would need to assign a bump map. So you can get the visual look of height and lowered areas.
But if it has like different colors, then I apply the texture with color and also bump map.
Correct.
Okay.
So for example, if you have fabric and say you're doing the exterior scene, you've got tablecloth. Tablecloth, sometimes the weave is it's not very fine, it's pretty loose, and you can usually see the weave. So you would need a bump map for the weave, and you'd need a diffuse map for the visual part. Like if it's a flower pattern or a checker pattern on your tablecloth, you would need that, or like your shirt.
Oh, so this is texture and the.
And the fabric would be bump.
Yeah. Oh, and are we gonna be able to create our own bump, or we need to use bump from mine?
No, you're gonna make your own.
And they also gonna be editable, like, we can, duplicate them and they not lose, without losing the quality.
Oh, you mean repeat them
Yeah.
if you need to. If they are repeatable. A lot of times for a bump map, you'll find something that is repeatable, because if it's fabric, it's gonna look the same as it gets smaller or bigger. So that's easy to make repeatable, but fabric is gonna be a little different, especially if it's like something like this where it's random. That's hard to make repeatable, because if I cut this in half and try and stitch it somewhere else, the pattern's not gonna line up. And that's what you have to worry about. And we'll get into that next lecture. So for the wall, we already talked about this being a single color, right? Can you see any visual surface relief on it? What? Yeah, it's too dark. So if I come over here and I put a light on it, can you see any, does it look completely smooth? No. So this visual part where it looks a little bumpy, that's a bump map. Does that make sense? Any questions? So remember, real time, if you're doing games, you're going to be using normal maps. If you're doing software rendering, you're going to be using bump maps. Like Substance, it'll do either one for you. It'll do height maps, you just tell it, hey, do I want a normal map, do I want a displacement map, do I want a bump map? And there's also things like, have you guys heard of Crazy Bump? Crazy Bump basically will take an image and it will generate different maps for you off of that image automatically. Yeah, some of them are okay, but what the good thing it does is it will give you a choice of, it'll show you your surface, it'll show you your texture, And it'll go, okay, I can make you a normal map, I can make you a bump map, I can make you a displacement map. And it'll show you what they look like. All right. So we found out how to make the texture or the bump on my surface smaller, right? Make it repeat more. And what I want to look at, let me render that out, because right now here we're just looking at a preview inside the hypershade in the material viewer. So let's see how accurate that view is compared to what I have here. All right, so you can see this looks a little coarser than this does. So don't always go by the material viewer, always render it out. Make sure it's accurate. Now, thing about bump maps is by default you get too much bump effect. You have to tone it down. Because with bump maps, just like with the surface, less is usually more. Like the wall, that's a very subtle effect. Fabric is a pretty subtle effect. That might be akin to something like really coarse stucco. I don't know. Maybe really poorly poured concrete ball. You know, too many air bubbles, it fell apart, too much sand in one thing, not enough calcium or lime in the other. All right, so in order to control that, we go into, let me move my network over here, into the bump utility. Bump utility has two controls that we care about. Value is what is driving the bump. That is your texture. That's coming from my noise. That's why it's yellow. That's why it's got a connection. This you don't want to change. That's based off your image. The bump depth is what you want to change. Bump depth starts out at 1.0. You want to lower it until you get the effect that your reference shows you. So for example, if I try and drop this down like halfway, and the slider's kind of sensitive, so you have to be careful of that. Keep image, re-render. This should give me half of the bump effect. All right, you can see, remember, it's all illusion. How do we know it's illusion? Let's look at what's called the alpha channel. Now, alpha channels in CG are there automatically. Alpha is what allows us to integrate our CG scene with live action or with another CG scene. It allows us to pile stuff on top of each other. So if I click on my alpha, you'll see anything that is white is opaque or kept. Anything black is transparent. So if I took this into Photoshop, I could replace this background here with any image I wanted to. But what it shows me is there is no real change in surface profile. Right? It looks coarse. It looks really rough. But towards the edges, it starts to fall off until 90 degrees, we get absolutely no surface change at all. Remember, everything we do in Maya is a lie. Everything in CG, it's all illusion. Now, so what you can do is, if you're not sure how much bump it should have, look at your reference. If you need to lower it, keep lowering it. Where do you start? Try cutting it in half. Whatever the default setting is, cut it down. So if it's a 1, cut it in half to 0.5. If it's still not enough, it's still too much, knock it in half again. Keep going until you get a result that matches your reference. So notice I'm just plugging numbers in because I'm trying to be pretty methodical about it. So let me go down to 0.1. That's roughly half of what I had before. Just render it out, and my bump effect lessens every time I turn it down. Now, one thing to be aware of, if you decide to use just the slider and drag it down, once you hit negative numbers, you will flip the bump effect. So the default is 1.0. If you flip it to negative 1.0 and render it out, it will invert what was raised and what was lowered. So if I compare this with my first, see, this area now looks lowered, whereas before this was raised up. So just be aware, it's a great feature to have if you're getting the reverse of your bump that you want. You just go into negative numbers. That way you don't have to go into Photoshop and flip your image, invert it, black to white, white to black. Right, does that make sense? Any questions on that part so far? All right, so let me take it back to, let's go 0.1. Because that seems to be not too heavy in the bump, but enough that we can finish the demo. So notice that I see bump effect on both the diffuse part where there's no reflectivity, no specularity, and also the spec part where I've got shiny bits. I can see it. Let's go in and take a look at what happens when I take this same bump and I plug it into standard. So if I select my material X, go down under bump, I could right click, I could break the connection, or I could simply take my out normal, which is right here, and notice this out normal part of my bump is plugged into overall. I can click on that little node, left click and drag it, and also plug it into standard. And then I can select overall and delete it. And now I've got it plugged into just standard bump. And notice it updated in my property editor and also in my, let's select that, and also in my attribute editor. All right, so I'm going to keep image, re-render this, and if all went well, you shouldn't notice a thing. It should look exactly the same. It all went according to plan. There we go, exactly the same. All right, so what I'm going to do is keep image, go into my attributes, and I'm going to turn on no diffuse bump. What that means is I will only see bump in the spec or reflective part of the material. This allows it to look like the bump effect is now on a coating rather than on the whole material. Right, so this is bump applied to both diffuse and spec. This is just the spec part. So it looks like coating now. Does not look like it's part of the object like that did. So anywhere there's no reflectivity, that's the diffuse part. Absolutely no bump effect at all. Looks nice and smooth. Right, does that make sense? Most of the time, I would say most of your applications for this are going to be in the diffuse and also in the spec. But if you need a coating change, something like maybe wavy glass, you might want to just put it in as standard bump with no diffuse bump checked on. All right, questions? Does that make sense with bumps? All right, I'm going to leave my bump on there. And let's talk a little bit about talk about diffuse maps. Right, we've already talked about the fact that if you've got more than one color you want to assign to a surface, you have to use a map. That part's pretty simple. So if you've got a wood texture, you need to assign a wood texture to your diffuse. So you can see the wood grain, you can see the wood color. Does anybody need to see a demo of that? You guys probably have a good idea of what diffuse maps are. If it's not clear for anybody, let me know. I'll be happy to demo it for you. What's that? What?
Let's do it.
Okay. All right. So I'm going to do this real simple. And all I'm going to do is I'm going to do exactly what you guys did when you were throwing on a texture into the scene to look at the UVs. Could tell whether they were lined up or not. I'm going to go into the diffuse part of my material. Under diffuse color, I'm going to click on that little checker icon. That's going to bring up my create render node. Right, so let's map in a 2D cloth. There we go. So the reason it's called cloth is because it's meant to look like woven fabric. It's a weave, right? And it's all illusion, right? It's got crisscrossing, kind of overlapping bands of color, right? The black part is meant to be between the weave. You've got one lighter part that kind of goes underneath the darker part that goes on top of it, and it just weaves in and out, just like real cloth would be woven. Right, so if I want to make this cloth weave smaller, I'm just going to go in and increase my repeat U and V. And I want to make sure that I'm using the place 2D that's attached to the cloth. So if I make it non-uniform repeat, I'll get some stretching. And Maya crashes. See, you're not the only one it crashes on. I'm surprised. It actually worked. Yeah, Viewport 2.0 is trying to show bump, but it's not very pretty. All right. So if I want my fabric to be even smaller, I just keep increasing my fabric until it gets to the size I want. Again, just as before, I can rotate this. And the cool thing is, if anybody's into animation, which if you right click on something and it says set key, yes, you can animate it in the timeline. So you can animate this going around. You can give your friends seizures if you want. All right, not only can you rotate the UV frame, you can also rotate the UVs themselves, which I'm not a big fan of doing that. I'd rather rotate the frame, keep the UVs where they are. This way, if I have to alter something, it makes sense in the real world. All right. So the whole idea is with a diffuse map, you got more than one color. You need to use a diffuse map to be able to see that on your surface. The scale or size of it's going to be determined by your reference. You know, how small does that weave in my fabric look? If it's much smaller, then I need to make this smaller until I get that weave. Now notice I'm using power of 2 because it's easier for the computer to calculate. Right, so that looks just like a giant sickly ball. All right, giant sickly bumpy ball. And for the material, I'm going to turn back on my bump so it applies to both the diffuse and the spec component, because it looked kind of weird. There we go. So now this is one of those big giant fabric balls you see in the mall that people throw at you when they're trying to get you to come into their store. All right, now let's talk a little bit about, first off, does anybody have any questions over diffuse maps, bump maps? Yes. And you want to delete it. Good question. So, to delete bump, a couple things you can do. You go into the attributes, my attribute editor, go down to bump. On top of the word standard or overall, whichever one you have it plugged into, you right click and you choose break connection. Once you break the connection and re-render, the bump effect should be gone. So now I've got a nice smooth sphere again. Now, when you break the connection, does it completely delete that little piece of network? The answer is no. It is still here. It is still in your scene file. So textures are inside here. There's my noise, utilities, there's my bump right here. There's my place 2D, which is number 1, that's right here. All that stuff still exists in Maya until you delete them. Now, if I want to reconnect this, as long as I have not regraphed my network or cleaned up my node editor, it's pretty simple. I can just drag this back into whatever attribute I want. Now notice my sphere didn't catch up. There it is, finally. Now that goes the same thing. Like if you plug that cloth in and you realize, I don't like that cloth, I want to put in another cloth that I found. You do the same thing. Go into the attribute. In this case, it's diffuse color. You right click on diffuse color, break connection. Now, if you break connection, it's going to give you whatever color it shows here. Sometimes it's an average, like if you've got more than one color, it'll show you an average between 2 colors or multiple colors. It'll just show you an average of what it was. It's up to you to return it to whatever you need it to. If you want to put it black and white, you can return it to black and white. You can make it a solid color. You can plug another texture in. Yes?
So for this project, we applying bump map to diffuse or to the, like, just to the bump?
Bump maps get plugged into the bump. Diffuse maps get plugged up here under color. If it's primary visibility, it's your base part of your material, which is diffuse. This shows primary visibility. If I delete this, that deletes my visible fabric. Right? Because I have no bump in here. So now if I go up here and I break my connection to this, now I've got a solid color now. That will happen with any texture you have plugged in there. Now, if I want to reconnect them, that's pretty simple. I'll just take my bump. I can take my out normal here, just plug it into overall. I can take my out color here from my cloth, plug it back into my diffuse. And now I'm back and I've got it all set up again. Right, does that make sense? Any questions? Elisa, does that make sense? Okay. Now, one other thing I want to talk about are spec maps. How to control reflectivity on your surface. For example, my surface is evenly reflective. In fact, let me turn this up a little bit more here, just to kind of exaggerate it. So I turn my reflectivity all the way up. And actually, for this demo, no, it's fine. This will work fine. Now, to show a simple version of a spec map, I'm going to use the checker because I got so much going on in this. I've got, a fabric weave in the diffuse. I've got noise in the bump. I want to have something that's easy to see with spec. A spec map gets plugged into reflection color. Okay, reflection color, all I do is click the checker. I'm going to go into 2D textures and choose checker. The reason I'm going to choose checker is because it's going to give me large squares that are black or white. And since I'm using them as a spec map, anything that is black is non-reflective. Anything that is white is going to be completely reflective. It's probably going to be a little hard to see it with the projector, but you can see here. These areas are not reflective. These areas are reflective. Also, notice up here. That square right there is the black part of my spec map. This square up here, this is the white part of my spec map. So it's allowing reflectivity. This is not allowing any reflectivity. And they're going to stagger. Reflective, 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 reflective. It's like a checkerboard or a chessboard. Right? Since this is black, this is going to be non-reflective, 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 non-reflective. Now, generally, you wouldn't have a spec map that makes no sense on your surface. You would have a spec map that's going to follow areas, that look like they're low-lying or look like they're raised. For instance, I always like to use the back of my phone. So you can see areas here where it's still fairly smooth, that's going to be pretty reflective. Areas where it's really rough and scratched, that's not going to be reflective at all. If it's reflective a little bit, it might be. But we would use a spec map for that. I would probably scan this in, or take a picture of it, take it into Photoshop, make it black and white, make it high contrast, be able to identify the lighter areas, maybe invert them to be dark because in my spec map I want this to be black. I want this part to be white. Any areas that are half and half would be gray. Transition between reflective, non-reflective. Questions? Does every surface need a bump map? No. You're right, it doesn't. Only if you see visible surface texture. Does every surface need a spec map? No. Only if you see an area that's reflective right next to an area that's non-reflective on the same surface. So for example, if somebody came along here and roughed up part of this tabletop, you'd be able to see it would be a little shiny here and then it wouldn't be shiny at all. So only when you've got a surface that's got more than one level of reflectivity on it do you need a spec map. It's very similar to a diffuse map. If you've got more than one color, you need a map. If you've got more than one area on a surface that's reflective and non-reflective next to each other, you need a map. All right, so let's talk a little bit about mapping. We talked a little bit about texture mapping, which is the default in Maya. Anything 2D gets put on in UV space. Projection mapping allows us to take a 2D texture and position it in 3D space. So we can move it around as needed. Now remember, with 2D, UV, you can only slide it around in U and V. With 3D, it then becomes X, Y, Z. I can position it, I can rotate it, I can scale it anywhere I want. We get that mostly for things like labels, decals, anything that's small and movable, or it might be movable. Because there's always a chance with something like that, you position it, your boss comes in and goes, it's got to be up a little higher. Mostly that's what bosses do, just to assert their authority. Where you had it maybe perfectly accurate with the reference, but he's artistically deciding it's got to be moved 2 pixels to the right. So you could either go back into Photoshop and move it around in layer, or you could just go into Maya and go move the controller and just move that projection over a little bit. So notice with 2D texture mapping, you get a map and you get UV coordinates. With 3D projection, you get a projection node. This projection node, think of like a car frame. It's a container. Right? These are your passengers. They're going for a ride in that container. This is your drivetrain. This tells you where you can drive it. And you can drive it in 3D space. So these 2D guys can now be driven in 3D space because of this, attached to this. This projection behaves a little bit like UV mapping. By default, it's planar, a solid flat plane. But you can also make it a shape. You can make it cylindrical, you can make it spherical, which helps, especially if you're going to do something like the thermos. The thermos is what kind of shape? Cylindrical. So cylindrical mapping makes sense because it will not distort the logo as much. It's not flat being put onto a cylindrical shape. It's cylindrical already, it's wrapped. All right, so we already talked about this. We're going to talk about this. Now, the key thing to creating a projection versus a normal texture mapping method is, instead of left clicking, you right click. And as soon as you right click, you get this little contextual menu that says, all right, you can add the textures if you want to create favorites. You can create it as a texture, which is UV, or create as projection, which is 3D. So for projection, you right click, create as projection, then you get all this extra network here. If you accidentally forget and left click, you will only get 2 nodes, and you will not be able to move them around in 3D space. So I can demo that using my plane that's right here. In fact, I don't even need to render this out because I can show you a projection in the viewport. All right, so I'm going to select my plane. And what I'm going to do is I'm going to assign my projection into the diffuse color. Remember, that's my primary visibility. So what I'm going to do is click on the checker button, go to Create Render Node, and I want to assign a 2D, but I want it to be a projection. And instead of using one of the Maya built-in procedurals, I'm going to use a file. I'm going to put the AAA logo on that plane in my scene. Now, instead of left-clicking, I have to right-click. If you do not right-click, you will not get a choice to make it a projection. Make sure you write yourself a note. Common problem is people forget, they left-click and they go, how do I fix it? Well, you got to make the network. All right, so create as projection. What did it do? Well, let's graph the ground and see what happens. So remember, it's the ground plane. All right, so plugged into my diffuse is my projection. Remember, that's the car body. All right, the engine, the drivetrain are down here. This is how I will position my car. These are my passengers. Right now, it's an empty file, and I want to put a passenger in there. So, in the file node, I'm going to go under File Attributes, Image Name, click on the folder, and I'm going to find my AAA logo right there. All right, so I'm going to click Open, and ooh, that doesn't look like a AAA. Wait, that doesn't look anything like this. What happened? Call tech support. Yes, I heard somebody had an answer.
It's distorted.
It's distorted, yep. Why is it distorted?
Because wrong projection, there's like the folder over there, and it's instead of being like a Y, it's on Z, I believe.
You are correct. That's because this little projection node right here, it actually looks like an area light. And you'll notice if I pull it out of the ground, it's got a little pointer just like an area light. It will project my texture, just like a projector, onto whatever direction that little normal is facing, that little antenna. Now, I can tell it's not an area light because in the bottom right corner, I've got a little diamond here. Depends on whether you're looking at it from this side or this side, whether it's right or left. But the bottom corner is going to have that little diamond. That says projection. And actually, when I select it, it doesn't show me the projection. It shows me the placement of it. So what I'm going to do is I'm going to rotate that 90 degrees. I want it to face down. So now when I do that, I can see it's rotating in X. So I'm just going to rotate that all the way 90 degrees. And now I've got an army of evil AAA minions. Dun, 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 dun. All right. Now, first off, when you're doing a decal, chances are you're not going to do a whole sheet of logos. All right, that's pretty ridiculous. Unless you're doing like one of those backdrop walls that they do for like award ceremonies where they put like logos all over the place and they just repeat them forever. That's probably not going to happen. So the first thing we want to do is figure out, why do I have multiple copies and how do I get rid of them? Right, so multiple copies are caused by my place 2D. That's plugged into my file. This is my AAA logo. Now, I'm going to click on my place 2D right here. And the thing that's causing that is this wrap U and wrap V. Because this is actually the size of the area where my logo is, but it's just wrapping itself and repeating it to cover the entire surface. So what I want to do is turn off wrap U and wrap V. Now I have a single logo. And I can move that around anywhere I want. I can scale that logo. Make it small. I can make it big. I can position it. I can do whatever I want. If this were a curved surface, I could rotate around it in 3D space. Questions? Yes.
Where did you find the
You have to go into the Hypershade and graph your network. and it's part of your Place 2D that is connected to your file. Yes?
The logo, it has white around it.
Yes.
Obviously, when we're doing the file, we don't want a block of white.
Right. So, good question. That's a two-part answer. First part is, I can show you how to make the rest of your surface the same color as your background. The other part is, what happens if I don't want that? And that's when we get into layering. So for the meantime, I realize you guys may have a white box on the table or the wall or wherever you're going to put a projection. That's temporary until we get into layering. Because layering involves using something called blend modes, which means I can remove certain colors so that when they lay on top of other things, it shows through. And I don't want to get into that yet. I just want to get into laying the groundwork for using the projection, and then we'll get into fine-tuning it, getting rid of what we don't want. Does that make sense? Yeah, so to answer your question, I want my white background to kind of blend in with the rest of my floor. So I want to basically make my floor the same color as my background. Now the reason that it's gray is because if I go into my file and I go down under color balance, you'll notice there's a default color. That default color is there whenever your projection does not cover the entire UV space. It needs to fill it with something. Or it would be green, you wouldn't have material there, it wouldn't render out right. So what it does is it's got a default gray color. It's pretty much that gray color you get with any default material that you build. So what you can do is take your default color and make it white, just like your background. And it changes it, it blends in. Now, like I said, it's going to come a time when we get into layering, which is lecture 10, where we're going to have a texture on there. So for example, that could be cobblestone floor. And I don't want my cobblestone to be white. I want them to be cobblestone color, just like my image back here. So this is where we get into layering. We get into what's called adjusting blend modes and basically removing white, keeping the black, and it shows through. So I realize it's going to be kind of a restraint for the next couple of times you work on it, but go with me because I want to try and build on each step. And if I try to introduce layering right now, it's way too much. So we just back off on layering part and just deal with this, and we will get rid of all the other stuff that we don't want. Yes?
Where I can find the quality of the image, if it's like all pixelated?
Couple things might be, go under renderer, make sure you got viewport 2.0. If it still looks pixelated, find another image because it's probably the resolution of the image is not high enough. Like if it's really small and you blow it up, it's going to look pixelated. Good questions. Any others? Does that make sense? All right, let me show you guys how to put the projection on the thermos. And the table is pretty much the same thing I just demoed here. So if you're going to put the SAL logo on the exterior scene, you would do this. Now, what you could do is you will just live with the white for now, and then we'll get into the actual color when we deal with it. Now, what you could do is put your placeholder color here under default. So, for example, say you got like a beige table. I mean, you would just deal with the white background or the white box until we get done. And then once we did this, you would just put this default color back to what it was, and we would be working with layers and everything would be fine. All right, so let me set my project. Oh, it's already set. I'm going to open up the interior. Yes.
Sorry. And when are we gonna project the logotype on table or on thermos? Is it fine to have it on the backside too?
I'm going to show you how to fix that. Because by default, a projection on your surface will go through everything. So if you've got a cube and you project it on the front side, you're going to see it on the back side. But I'm going to show you how to get rid of that at no extra cost. All right, so here's my thermos. It's got thermos material type on it, brushed metal. What I want to do is take my color, my diffuse color. Remember, that's where projections are going to go, diffuse color. I'm going to click on my diffuse color checker, go to 2D textures. If I want to get a projection, what do I need to do? Right click, thank you. Right click, choose create as projection. In your file node, this is where you want to plug in your logo. I'm going to choose the AAA logo. There we go. But where is it? It didn't show up. Yes. Everybody hear that? Just like anything else in Maya, default drops in at the origin, center of the world. So let's go hunt and peck where that is. There it is, all the way over here. Thank you, Maya. So what I'm going to do is just position it roughly over here. And I overshot the landing. There we go, right there. Whoa, yeah. All right, so now I'm going to go back. And that looks just adorable. So it looks awful. Go up, make sure you've got viewport 2.0 running. There we go. So it still looks awful. And there's a couple things going on to help in its awful look. One is I have many of them repeating. So first thing I want to do is get rid of the repeats. Anybody remember where that is? Say it. Yep, place 2D texture right in the hypershade. So we're going to bring up hypershade, and now I got to go through. Fortunately, I named all my stuff. It's not like MIA Material X 1 through 70. So I actually labeled stuff, and I can figure out, okay, that looks like the metal part. That's what I want. There we go. So I graph it. There is my network, my AAA logo, my projection, my place 3D. Here's my place 2D. I check off wrap U, wrap V. Now all my evil minions are gone. Notice it is projecting through to the other side. So what I want to do at this point is select my projection, not the place 3D. I want to actually go here in my hypershade. So I select projection. Here I get my projection type. I'm going to change it from planar to cylindrical because it is a cylindrical object. Now notice it disappeared. Why is it not projecting on my thermos? Well, it has to actually touch. There we go. My logo should be, if you use the reference we provided for you guys, it should roughly be halfway in the body, and it should be proportionate. Right now this is not. So if I want to interactively adjust this rather than just use my scale, rotate, translate tools, I can use what's called interactive placement, which gives me this cute set of tools. And if I want to rotate, I can click on my little diamond down here, choose rotate, and then I can come in and do this. Rotate it around. And notice Now that I've made it cylindrical, it does not project through to the back side. Last but not least, what I want to do here I want to get rid of that gray part of my material because that's not what my material would look like. This is where default color comes in again. So I go into my logo. Default color is gray. I want it to match my background. What color do I make it? White. So now when I render this out, it should more or less give me my thermos. Ooh, I better check my render settings. Yeah. Okay. So now when I render it, it should show up in the right position. So maybe it's too big, I scale it down, use the interactive placement. If what turns out white? What does? If the render is white, the whole render? You probably want to check your material properties. Don't forget, this thermos is what kind of material? It's metal. Right? So if it's metal, you want to make sure you got metal material plugged in. You also want to make sure you have anisotropy turned on, right? You got it rotated properly. You have to go under BRDF to increase the 0 degree reflection. If your 0 degree reflection is too high, it's too much of a mirror and not metal. Yes?
I was going to say, is leaving because I thought when you were render it was going to be white because you changed the base color. Is that just because it's only in the diffuse?
Yes, that's because it's only in the diffuse. And the diffuse is not contributing that much to it. Remember, reflection plus refraction plus diffuse equals 100%. So my 0 degree is roughly 60%. That means I've got 60% reflectivity. The other 40% are going to be diffuse. That's why it doesn't show up pure white. Now, like I said, later on when we get into layering, we'll be able to make this so it's not as shiny because I don't have my thermos today. It's going to be a little gray. It's going to be a little darker. So we would put a darker color layer. We would get rid of the white and just have the logo sit on the actual color that we need. Again, layering, but this gets you at least to the point where you can put stuff on. And like I said, you only really need in your scene to have one projection. If you choose to have more, that's fine. But we only use projections for small things like this that are movable. You would not use it for the floor or for pillows or anything else like that. That should be put on in 2D and just positioned properly. All right, does that make sense? Now, so far, we've talked about bump mapping, we've talked about spec mapping. The thing that they both have in common is that they are both black and white maps. You will find that black and white maps go a long way for being able to control attributes in a material. Remember, in your material, anytime you've got a slider like glossiness that goes from 0 to 1, you can plug something into it that's black and white, because black is 0, white is 1. And that's why there are so many areas you can plug stuff into in the materials. You can control glossiness with it. You can control transparency with it. You can control refraction transparency. You can control anisotropy. You can control anything with a map if you want to. Scalar control, 0 to 1. Right. The only thing we didn't get to is cutout opacity maps. We're actually going to get to those in lecture 10 also, because that involves removing unwanted parts of geometry at render time. So if you're going to do the exterior scene with a label, you're going to want to cut the wine out so it looks like it's glued onto the bottle and not put on with just the cylinder. You know, wine labels they usually spend a lot of time and money on so that they have nice shapes and they're positioned on the bottle. Even if it's a square or rectangular one, they're still not going to usually wrap around the entire bottle unless you've got really cheap wine. But we will get to those. All right, last minute questions before I send you guys off. So today, you're going to start to think about which scene you want to work on. Start gathering reference, start looking for textures also. All right, so go to lunch. Come back at, don't come back at 10 a.m. Let's see, go to lab. That is FS4B 128 at 6 o'clock.